Graphing rational functions. As you discovered in the discovery activity today, there's several things you need to know before you can graph a rational function. You need to know if it has asymptotes, whether they're vertical, horizontal, or in some cases even oblique, which some of you discovered today. I found in the activity that I got lots of descriptions of the asymptotes and how we found the asymptotes, and there were some groups that did figure out how to find it from the information you had calculated. So first of all, the vertical asymptote actually comes from the denominator, and you basically set the denominator equal to 0. And I liked how one group said factor and then set it equal to 0, which is a really good idea because that helps you find that asymptote. And the asymptote's always written as a line. It's x equals something, okay? And it's always a line x equals, because remember, all the x values are going to be the same, so that's got to be a vertical line up and down. So it's always going to be x equals something, and it will cross the x-axis. So for example, if I had f of x equals 1 over x squared minus 4, I could factor that, and I would get x minus 2, x plus 2, and then I set those equal to 0, and so it will have two vertical asymptotes, x equal 2 and x equals negative 2. So remember, it can have many vertical asymptotes. You just take whatever the denominator is and set it equal to 0. And there were some groups that figured that out today. Now the horizontal asymptote, that one is difficult. That one's a little bit more difficult, and it has to do with the degree, which is why I had you fill out that chart of finding the degrees of the denominators and the numerators. And that's where our little saying, Bobo, Boatin, eats DC comes in. So Bobo means big on bottom 0. And Boatin means big on top none. And eats DC means the exponents are the same. So you divide the coefficients. Now this is just one way to think of it, and I don't care if you remember this saying as long as you remember how to do it. So for example, if I have the function f of x equals 1 over x minus 3. When you ask yourself about Bobo, make sure that Bobo is always referring to the degree. Okay, so we have to compare the degree of the numerator and the denominator. So the degree of my numerator is 0, because there's no exponent there. If I wanted to put an exponent, I'd have to put x to the 0. So the degree is 0. The degree of my denominator, remember the highest exponent would be 1. So the degree is bigger on the bottom. Okay, so I would be thinking Bobo. And when it comes out to be Bobo, it's 0. So my horizontal asymptote would be y equals 0. If I look at another example, if I had g of x equals x over x minus 8. So I would still start the same way. I'd compare my degrees. So the degree of my numerator would be 1 because the exponent is understood to be 1 there. And the degree on the denominator would also be 1 because it's understood to be a 1 there. So since these exponents are the same, it's going to be eats DC. And eats DC means that I'm going to divide the coefficients. So you divide the coefficients of whatever you got your degree from. So I had an understood 1 here and an understood 1 here. So I'm going to do 1 divided by 1. So the answer would be y equals 1. If I have, let's say I have x cubed over x squared minus 1. Okay, the degree on the top is 3. The degree on the bottom is 2. So it's big on the top, so that's Boatin. So it's going to be none. That means there's no horizontal. Now we're going to learn later on that if there isn't a horizontal, there might be an oblique. So we'll have to look for obliques when we get into the next section. Just to take another example, let's say I had j of x was x squared minus 3x plus 2 over 2x squared plus 4x minus 1. Now I don't have to worry about factoring these to figure out the horizontal asymptote. All I have to do is look at the degree. So the degree of the numerator is 2. The degree of the denominator is 2. So that means that exponents are the same. So I'm going to divide the coefficients. Now remember, when you divide the coefficients, you're dividing the coefficient of the one where you got the degree from. So I'm dividing by 1 by 2. So the answer will end up being y equals 1/2. Because I'm dividing the coefficient of x squared here, which is 1, by the coefficient of this x squared, which is 2. So we end up with our asymptotes. So the first thing you need to know the asymptotes before you can graph a rational function. Now the other saying that we mentioned in the discovery activity that some groups remembered and most groups did not is RATEY. And I'm going to talk about this in class tomorrow. But realize that knowing what RATEY means is just a way to help you figure it out. And R stands for roots. And one of the ways RATEY can help you is you're going to start at the top. Okay, so I start at the top, so I set my numerator equal to 0. And that gives me my x-intercepts or my roots. So they're going to be recorded as a point, and it's going to have whatever the x number was, comma 0. And you could have one root or no roots or more than one root. Then the A stands for asymptote. But realize this is the vertical asymptote. So when I say VA, I'm talking about the vertical asymptote. So we just talked about it a few minutes ago. It's the denominator equal to 0. But you have to realize that it's still the x, but this time you're saying x equals some number instead of just putting some number comma 0. So you have to remember that the roots are the first thing, the asymptote is the second thing. Then the T means together, and for together you just put yes if it's a special square. Like if I had x plus 3 in a parenthesis with the squared on the outside, that's special. If I had x squared, that's special. Or no, if I have anything else like x squared minus 4, or if I had x plus 2 times x minus 3, these two are not the same. So to be yes, they have to be the same. And what together means is the graph is going to come together at this asymptote. So if I'm looking at this function right here, if I have x plus 3 squared, then negative 3 is where the vertical asymptote will be at. But when it says that it's coming together, okay, coming together means that if my x-intercept and y-intercept were, say, here and here, I would draw this part, and then the other side over here, let's say there's another asymptote down here, then it would have to come together. So it tells you something about what happens right here at the asymptote. If you put yes, you know it's got to come together. If you put no, then it's not going to come together. E stands for the end behavior. And that's your horizontal asymptote. So that's where you're using your BOBO. And make sure that you record your answers as y equals some number. And then y stands for the y-intercept. And you just put 0 in place of x. Or you're just finding f of 0 is really what you're finding to do the y-intercept. And of course the y-intercept, you're going to record your answer as 0, comma, some number, whatever your y is that you figured out. So knowing how to do this is going to help us be able to do a graph. So let's just take a simple example. Let's say f of x is x over x minus 3. So I'm going to start by drawing myself a graph. Now in pre-cal, I will not ask you to actually tell me the RATEY. I will actually just ask you to fill in things like the x-intercept, the horizontal asymptote, the vertical asymptote, and the way we talk about things will be a little bit different. But you can still use RATEY if it's helpful to you. And so I think sometimes having some way of helping us remember how to do something helps. So I'm going to start by doing my RATEY here. And so remember, the first thing you would do is set your numerator equal to 0. So my numerator is x, so I would do x equals 0. And of course I get 0, so the root is 0, 0. So I'm going to go and plot that over here on my graph. So I know 0, 0 is a point. And then the asymptote set the denominator equal to 0. So x minus 3 equals 0, so x equals 3. So I'm going to write x equals 3 here for a. And then you go over here and you make a dotted line. And I want to see that labeled, so you're going to label that with x equals 3. And then the t, this is not special square, so if it's not a special square, you're going to put no. E is your end behavior, so I'm looking at the degree. The degree is exponents are the same because these are both 1s. So I'm going to divide the coefficients, so 1 divided by 1, so it's going to be y equals 1. So I'm going to go to y equals 1 and draw my dotted line. And again, make sure you label your asymptotes, so it'll be y equals 1. And then your y, you're going to put 0 in place of x, so I'm going to find f of 0 and get 0 over 0 minus 3, which of course is just 0. So my y-intercept is also 0, 0. So remember, these asymptotes, as most of you figured out in the activity that we did in class, that it has to get close to those asymptotes. So if I know I've got this x and y-intercept right here, I know that it's got to be going this way towards the asymptote, and on the other side, it has to be going this way towards the asymptote. So I'm not going to be as picky about exactly where that point is, but I need to see that it is getting towards the asymptote. Now over here on this side, we can't have a blank area. Okay, so it either has to go down here or up here. That's where your together comes in. Since it's no, I can't put it down here. So I know it has to be up here. And so that is the second part of my graph. So that's how the t helps you to figure out how you're going to graph it. So tomorrow we're going to look a little bit more at rational functions, and we're going to figure out what those holes are and why we need to know those holes. And then we're going to start actually using our RATEY to graph it.